Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 56 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice enormous mug of iced coffee. That would be strong black coffee poured over ice, no sugar, no sweetener, none needed. I'm also going to need you to get out your Jetson Nano gear and get ready to learn some cool new stuff. As you're getting out your gear, as always, I'm going to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, think about looking in the description below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. Finally, after 55 lessons, we are going to learn how to interact with these GPIO pins on the Jetson Nano. We're going to learn how to control things from the Jetson Nano through the GPIO pins. Now, why would you want to do that? Well, because we can have our Jetson Nano, and with all the artificial intelligence that we have learned how to do so far, we can understand what is happening around us. We can look at scenes, we can take them apart, we can know what is around us, so we can kind of understand our environment. But now we want to be able to do something based on what we see, what we've learned, what we know. Well, what would you maybe want to do? Well, maybe in certain circumstances you would want to unlock a door, or maybe you would want to lock the door, or maybe you would want to turn a high power laser on, or maybe you would want to turn a fan on or off, or open a window, close a window. There's all types of things that you might want to do based on what you know, based on your artificial intelligence. And you do that through the GPIO pins. So that's what we are going to learn about today. And you guys that have worked with the Arduino sort of understand about the GPIO pins on the Arduino. Well, what we're going to do today is learn the GPIO pins on the Jetson Nano. Now, I will say that I have spent 4 or 5 days working on getting all of this figured out, and I will say that my first impression of playing around with these GPIO pins is I was kind of disappointed. All right, I was kind of disappointed. I'll tell you today why I was disappointed, but don't get discouraged, because we're going to be able to do everything that we want to do and everything that we need to do. We've just got to think about things in a little bit different terms, and that's what I'm going to kind of teach you today. And so let's talk about my disappointments. My first disappointment is that the first time that I tried to access these GPIO pins, I was working on Jetpack 4.2, and on Jetpack 4.2 you had to go in and you had to reconfigure system files to make the GPIO pins available, and I carefully followed the documents and I carefully followed the instructions, but I was simply not able to make the GPIO pins work. The good news is that on Jetpack 4.3, which all of you guys should be on by this point, they make accessing the GPIO pins much easier. You don't have to go in and edit system files. You just have to give commands in the command line or give commands in Python to access them. So Jetpack 4.3 has made the GPIO pins fairly easily available. Now, the second disappointment that I had in the GPIO pins on the Jetson Nano is they're 3.3 volts. Now, the GPIO pins on the Arduino are 5 volts, and so that means if we've bought components along the way, interesting accessories for our Arduinos, those probably are designed to work at 5 volts, and they're not going to work on 3.3 volts. So by going to 3.3 volts for those GPIO pins, a lot of the gear that we have in our little supply cabinets are not going to work with the Jetson Nano. Okay. Third disappointment that I had with the GPIO pins is that they are very, very low current. They only produce a very small amount of current. Now, the GPIO pins on the Arduino are very hefty, and so you can do things like turn on an LED or power other parts of your circuit. So what that means is that with the Jetson Nano, you've got to start thinking about things differently. You're not providing power to turn something on or off, or you're not powering things from the Jetson Nano. You're sending control signals. You got to think of it in terms of control signals. You're sending a signal that you want the LED to turn on, or a signal that you want the LED to turn off. You're not powering the LED itself from these GPIO pins. And that's what I'm going to show you today. We're going to go through an example that I'm going to show you in this new way of thinking how to turn an LED on or off. And if you can turn an LED on or off, then you can start doing all of these other things. But it requires a different way of thinking. But never fear, I'm going to teach you how to think that way today. The fourth disappointment that I had with the GPIO pins on the Jetson Nano is they are very, very sensitive to the capacitive load that you hook to them. So the first thing that I did was I tried to turn the GPIO pins on and off, and I had my digital voltmeter with these cables, and I could not detect the voltage coming on and off. It would, like, instead of going to 3.3 volts, it would maybe go to 1.6 volts and then wouldn't turn off, and it was just like really kind of like incorrect behavior. Well, what I learned is that these pins are very, very sensitive to the capacitive load that you connect to them. So great big long wires like I have here with this voltmeter, this digital voltmeter, they have too much capacitance, and the Jetson Nano GPIO pins are not able to drive those. Similarly, I then went over and hooked them up to a oscilloscope with this low capacitance probe, and still it didn't work. I had to put this in the very low capacitance mode and able to finally start seeing things on the seeing things on the oscilloscope. But once I understood that you've got to be concerned about the capacitive load, then I can make it work. Well, the good news is with little circuits and short wires, we should be okay. But just understand that if you hook a voltmeter up to try to see the voltage coming up and down, you probably are not going to see it. At least that was my experience. And so those were the things that my first impressions of working with them. But then playing around with it a little bit, I kind of figured out how we can do the things that we want to do. And the idea is this idea of you're not providing the power for the device you're trying to control. You're just providing a control signal, and then the power comes from somewhere else. And so let me sort of show you. I think I will move over to our most excellent sketch view and try to kind of talk to you a little bit. The key of making this thing work is this magical PN2222 transistor. Now, this is one of the earliest semiconductor devices to come out. I remember working with these things back in the late 1970s, early 1980s, and so this is kind of like one of your core fundamental electronic elements. And what I'm going to do today is I'm going to tell you how you can use the PN2222 transistor. Now, if you have the most excellent Elegoo Super Starter kit from our Arduino series, it has one of these transistors in it. If you don't have the starter kit, you might think about going ahead and getting one, because it's a whole lot of components that are very useful to be used in all types of projects, and it doesn't cost very much. So you can look down in the description below if you want to pick yourself up a kit, or you can just look at Amazon. These things are about 10 or 20 cents a piece depending on how many you buy, and so you can just order them off of Amazon if you want. But to really use the GPIO pins on the Jetson Nano, you're going to need some of these PN2222 transistors. Now, how do these transistors work? Well, let me try to explain how a transistor works. First of all, you will notice that the transistor has three leads. Okay, the transistor has three leads, or three wires coming off of it. And those three leads, or those three wires, are the emitter and the base and the collector. And I will show you here the symbol for the transistor. The symbol for the transistor has 3 leads coming out, like such. This is the collector, this is the emitter, and this is the base. And the way to think about it is you control the collector and emitter through the base. And so one way to think about this is an on-off switch. If you put 0 volts on the base, you won't get any current between the collector and the emitter. If you put a voltage on the base, you turn it on, and then current will flow from the collector, kind of like from the collector through the transistor and out the emitter. So you can look at it as a switch. The other way you can think of it is you can think of it as an amplifier. And so whatever current that you have here, your base current, IB, your IE, your emitter current is going to be equal to about 100 times your base current. And so this is how they did the very early, like back in the early days, did amplifiers, that if you hooked a microphone to the base, that has a very small current coming out of it. You amplify that current through the transistor, and then you have a large current in the collector or the emitter, and you could like run run a speaker. And so a transistor is used to amplify, or it is used as a switch. And today we will be using it as a switch. So how will we make this LED work? Well, let's go back and think of the old Arduino days. In the old Arduino days, you would maybe, let's say that we have pin 9, and you would come from pin 9 over, and then you would go through a current limiting resistor, and then you would go to the diode, and then you would come back and you would ground things back at the Arduino ground. Now, if you turn pin 9 on, the LED comes on. If you turn pin 9 off, the LED goes off. Now, why could we do that? We could do that because the Arduino provides enough current to drive the LED. The thing is, the Jetson Nano cannot. The GPIO pins on the Jetson Nano cannot provide enough current to really drive a LED. So what do? Well, we build a different circuit. And so I will start with the transistor, the emitter, the collector, and the base, the collector, and the emitter. And still, as before, we are going to ground the emitter, and this will be the Jetson Nano ground, and so this would be connected to the Jetson. That is just too terrible. I wish I could write better on this graphics tablet, but I struggle mightily with that. And so this will be the Jetson ground pin. Okay, and if you look over here at the GPIO pins, a lot of those different pins are labeled as ground, and you can use any of those. Then what I'm going to do here is I'm going to put my diode in this part of the circuit up connected to the collector. So I would have the short leg of the diode LED connected to the collector, and I am still going to need a current limiting resistor, and so I will put that there, and then this is going to be my VCC. Now in this case, I'm going to get the VCC, I'm going to get the 5 volts from the Jetson Nano, and so this would be the Jetson 5-volt pin, because that 5-volt pin can actually provide a fairly large amount of current, a fairly reasonable amount of current, so you can drive your LED from that 5-volt pin. Now, in general, you guys should not be using your Jetson Nano as a power supply, and so if you don't have a good desktop power supply, I'm going to recommend that you get one, and there's a couple of different options. The first one is let me switch over there. The first one is this one, and I've got a link down below over to Amazon where you can get this. This is a very good benchtop general purpose power supply. It's about $54. You can use this in all your other projects, okay? kind of disappointing thing is that's kind of expensive. And so if you want just sort of a bare minimum way of doing it, you could use this one, and I'll include this link as well below. This is a wall wart for about 16 bucks, and it just has a little switch. You can provide 3, 4.5, 5, 6, 7.5, 9, or 12 volts out. And then also it's nice because it's got these different connectors. So this is the particular connector I really like because it allows us to do things like power this. Do you remember this this driver board for our servos? Well, you could bring the servo power in here using this. And so the bottom line is you really should not be using a $100 board, or in the case of the Jetson Xavier NX, a $300 board. You should not be using an expensive board as a power supply, because if you did something and hooked something up wrong or didn't calculate something right, and you end up burning out your computer because you're using it as a power supply, it is not a very good idea. But today I'm going to be using it as a power supply for the 5 volts because I'm using current limiting resistors. I'm hooking it up carefully, and a diode does not draw that much current. So let's move on back over to our drawing view. And so what we are going to do here is, like we were saying, we're going to get the 5 volts here from the Jetson Nano, which I believe is pin 2. Okay, it's pin 2. We're going to come down through a resistor, and then we're going to go through a diode, and then through the transistor to ground, and the ground goes on the Jetson Nano. Now this base is how we are going to control things. We are again going to put a current limiting resistor in here, and then we're going to come over to the Jetson Nano GPIO control system. Now there are a lot of GPIO pins on the Jetson Nano. Today we will be using pin 7. Okay, so this will be pin 7, and this is on the Nano. So we will be using the Nano pin 7. Okay. Now, what value resistors do we use? Well, always, you kind of know for these small LEDs, a good value is about 330 ohms. That will keep you that will limit the current so that you won't burn out the diode. Okay, and then for this current limiting resistor coming from the Jetson Nano, we're going to use 10K, and that is 10,000 ohms because we're not drawing very much current. We're just using the transistor as a switch. And so that, my friend, is how we are going to hook this up. Now, a couple of things that I need to show you is what the pin out is on your little PN2222 transistor. And the way that we can think about this is that if you hold the flat side to yourself, okay, the flat side to yourself, and you're looking down on it, this pin is the emitter, this pin is the base, and this pin is the collector. So flat side towards you, the left pin is the emitter, the center pin is the base, the right pin is the collector. All right, so that's kind of what you need to know there. And so I think I am going to switch my view over here, and with a little luck, with a little bit of luck, I think I can get this where you guys can see me building. You guys will be able to see me as I build this. So I will be using a small breadboard, and let me make sure that I get a good focus. I'm going to come back over to this other view, and guys, I'm sorry that I get slowed down on this focus, but that autofocus was driving me crazy, so I would rather take a minute and just get a good sharp focus, and then you guys ought to be able to see what I'm doing. So I've got the breadboard. That was no fun. Okay, I've got the breadboard. I've got the PN2222 transistor. I've got a 330 ohm current limiting resistor for the diode, and then I have the red LED. So let's see if we can put this up, and then of course I've got wires to hook up to the Jetson Nano. So what I'm going to do is I'm going to hook this with the emitter to my left. So I'm going to put this with the emitter to my left, so that means the flat side is towards me. And I'm going to kind of start on the left side of the board. All right, and so now if we go back over to this view so that we can see the circuit, you can see that the emitter, right here, the emitter goes to the Jetson Nano ground. And so I'm going to bring my Jetson Nano in, and I'm going to find a suitable wire. Let's see here, give me just a second. Okay, the best kind of wires are the males to females on this, but the emitter is on my left, and I'm going to use a black wire into the same column as the emitter, right? The same column as the emitter, and then I'm going to bring this over to a ground, and I'm going to be using, it looks like pin 1, 2, 3, 1, 2, 3, 4, 5, 6. It looks like pin 6 is a ground. So I'm going to put that into pin 6. Do you see how that's labeled ground there? Pin 6. And let me show you how the pins go. I guess I didn't mention that this is how the pins are labeled on the Jetson Nano. So let's see here. Do I have a... Okay, here we go. And so the way the pins go is that, let me get, I have pin 1 and pin 2, and that's the top row. So if you come over here and you look at that very first pin on the outside, that's pin 1. And so it goes like pin 1 is the outside pin, pin 2 is the inside, pin 3 is the outside, pin 4 is the inside, pin 5, pin 6. And so I guess I'll draw it like I've got it configured there. And so it would be, here is the Nano board, like that. And then this is pin 1, 2, 3, 4, 5, 6. So this is like pin 1, pin 2, pin 3, pin 4, pin 5, pin 6. So you can see that it is the outside pins are the odd ones, the inside pins are the even ones, and it actually has pin 1 labeled and pin 2 labeled. And so if you look, the pin 1 and the pin 2 are labeled, so it kind of gets you started in your counting. All right, I hope that makes sense. So let's come back over here. And so I have the emitter, connected to ground, and so I have done that connection. And now the base needs to go to a 10,000 ohm resistor and then to pin 7. And so I need to find my 10,000 ohm resistor, which I have here, again, came out of the Elegoo kit. And I am going to put it on the same column as the center pin. Okay, that will be the base. Right, do you see that? Do you guys want me to go to the full view here? Okay, so do you see how I have this 10K resistor in the same column with the base? And then I'm going to kind of fold this over and come way over here to this other part of the circuit, this other part of the board. And now this other end of that resistor, needs to go to the control signal coming off the Jetson Nano. And for us, that is going to be pin 7. All right, so I'm going to come and I'm going to now connect to the other side of that resistor. And then I'm going to come over here and I'm going to go to pin 7. Now there's a couple of things. Pin 7 is on the outside, and remember it's pin 1, 3, 5, 7, because the outside pins are the odd ones. And so now I have my control pin hooked up. So now we just need to put in the LED. So we will come back over here to this view, and you can see that the long leg or the short leg of the LED will hook to the collector. So the short leg of the LED connects to the collector of the transistor, like that. Short leg is in the same column. Let me see if I can let you see that really well there. Okay, do you see I have that short leg in the same column as the collector? And now I need to put the long leg. The long leg needs to have the 330 ohm current limiting resistor. And so now on the LED, I'll give you a little more focus here. That was on the wrong thing there. Let me click off of that. Okay, let me give you a little focus now. I go back and look at some of my old videos on the builds where the camera's out of focus. And yeah, that's really bad. I would rather pause a second and get the focus right. So now one leg of the resistor is going to hook in the same column as the long leg of the LED. And then I'm going to bring it over a little bit into another column. Just make sure that this resistor, the top leg of this resistor, is in a different column as the top leg of the other resistor, because you don't want those talking to each other. Okay, and so now that is in there like that. All right, and so now I need to take the top of the collector going to the diode going to the resistor, the top of the resistor. I got that silly thing again. Okay, now we are up here. We are up here, and that needs to go to VCC, which is pin 5 on the Jetson Nano. And let me show you how, or it's not pin 5, it's pin 2. Okay, it's pin 2 is the 5 volts. And so that is the leftmost row, all right, the leftmost column. The inside pin is 5 volts. And you should be able to see that because it's marked 5 volts. And so that is pin 2, and I'm coming in, I'm connecting to pin 2. I love this acrylic case, but it does make it a little bit harder to have access to the GPIO pins. So that's the only thing bad about the case. Now I will bring that wire into that resistor. Okay, so I'm trying to make this as clean as I can so you can see it as easily as you can. Okay, so this current limiting resistor that goes to the diode is going to go to the 5 volts on the Jetson Nano, or if you have your power supply, power it through your power supply. But that looks pretty neat. Okay, so I think we've got the circuit hooked up at this point. So now I think I need to move this over, and we need to go back and we need to call up a terminal window. We need to open up a terminal window back over at our Jetson Nano. And what I think I'm going to see is I'm going to see if I can give you a little bit bigger view. A little bit bigger view, okay, of the camera up here, so you can kind of see what is going on as we're doing this. And we're going to open up a terminal window, like this. Okay, and now we are going to go in, and we could write a Python program, but I want to do it from the command line. I want to do it from the Python shell, and the way we get to the Python shell is just say Python 3, like that, and then you see those 3 little arrows. That means each thing that we type is 1 line of code, but it executes 1 line at a time. Now we could go to Visual Studio Code and we could write the program and run it and write it and run it as we normally do, but if we do it from the Python shell, we end up with something that's a little bit more interactive, and so that's what I want to do. So the first thing you want to do is import the GPIO libraries. And the good thing is with Jetpack 4.3, these libraries should already be on your system. So you should just be able to say import, if you spell it correctly, import, and then RPI. Okay, import RPI.GPIO. Now notice it's uppercase R, uppercase P, lowercase I. You have to do the case just right, and then import it as GPIO. So we're going to import the library as all uppercase GPIO. Now we've got to tell it what numbering schemes we are using. We got to tell it what numbering schemes we are using for the GPIO pins. Well, to me, I want to use the physical layout of the board. And so this board, this physical layout already has a numbering scheme, right? It goes 1, 2. I got a little window issue over here to deal with. Sorry. It's like I lose my cursor, and then it drives me crazy. Okay, so I want to use this physical. I want to use this physical pin layout where, right, it's like outside 1, 2, 3, 4, 5, 6. To me, that's just very logical, and they are already labeled that way. So I want to tell it to use that layout, which is called the board layout. And so what we do is we come over and we say GPIO like that, and then set mode. And then what mode do we want to set? We want to set GPIO dot BOARD. All right. Now, when we do that, what that is doing is it's telling it to use this numbering system as we send commands. And so that looks really good. Now we are ready to talk to pin 11. Okay, we are ready to talk to pin 11. And so we got to do in Python what was sort of like the Arduino equivalent of a pin mode. We've got to tell it whether it is an input or an output. And we do that with GPIO dot setup. What am I going to set up? I'm going to set up pin 11, and then I'm going to set it up as a GPIO dot, and then out, all uppercase. And this is saying that I want pin 11 to be an output. Oh, it doesn't like that. What did I do wrong? Oh, I know what. I'd played around with this. I'd played around with this before bringing you guys on. And so I need to do, and you're going to learn a new command here. I'm going to need to do a GPIO.cleanup. You guys will not need to do this, but that just releases everything. Okay. Now with that, I need to go back and I need to give it a set mode of board again, because it forgets the set mode. It forgets the pin configuration when you do a cleanup. And so that now it knows what that is. Now I need to set GPIO.setup. I need to set up pin 11 as a GPIO out, and now it works. But last time I'd already interacted with that pin. I'd not done a cleanup, and therefore I got the error. All right. Now, ladies and gentlemen, it is the moment of truth. It is the moment of truth. And what we are going to do is we are going to do GPIO, okay, dot output. So I'm going to output where? To 11, and I want 11 to be true. Okay, and then I hit enter, and nothing happens, which means I don't have my circuit hooked up right. Okay, so now I need to do a little debugging on my circuit. First of all, let me make sure I'm on pin 11. 1, 3, or oh man. Were you guys screaming at me? I said I was using pin 7. I said I was using pin 7, and then I did all this for pin 11. That was really terrible. So how do I recover from that? Well, the set mode command is still good, and I just need to go to pin setup, GPIO setup, and I am on pin 7, 1357. I'm on pin 7. Okay, it likes that. And now I'm going to say that GPIO output, and I am on pin 7, and I'm going to say true, and it still doesn't work. 1357. This is indeed 7. So now let's go in and let's see where we made a mistake on the circuit. So I'm looking very carefully here. It looks like you guys, let me give you a little better focus there. Okay, so I've got the emitter to ground. The emitter is in ground. Okay, that's really good. And then my base pin, I've got hooked through a 10K resistor, and then that goes to pin 7, and then I'm powering everything with pin 2. And then let me just make sure I have my LED in the right direction. The LED is in backwards. It's the short leg that should go to, there it is. All right, so I hope you guys caught that. I confused long leg and short leg. So let's go back over to our view here. Okay, and the mistake that I made was the short leg. Let me move this out of the way. I'm having an awful time with my tablet today. Okay, the problem is that this bottom node, that is the short leg, and it is the long leg that goes to the positive. So that's the long and that's the short, and I had that hooked up wrong, and that is where my mistake was. But what, and you guys know that I don't edit out my mistakes, because I want you to see one of the most useful things that you'll learn here is how to troubleshoot something. And it's not about doing things perfectly. It's about finding your errors when you make a mistake. And so let's think about what we did there for our troubleshooting. The first thing that I did was I looked and I saw that I was sending commands to pin 11 to where physically I was hooked up to pin 7. I corrected that mistake, but it still didn't work, and so I checked the circuit connection by connection, and then I see, the connections are right, but it must be the diode. I turn the diode around, and then everything works. All right, so now let's go back and let's come over here. And let's think about how would we turn it off. Well, what would you guess? You would guess probably that we would set it to false. Boom. Okay, let's go back to true. Boom, it is on. Okay, guys, we are working with the GPIO pins. And the only real difference is to see that we're not driving the LED from the GPIO pin. We're getting the current for the LED from the 5-volt pin, and then we're just controlling it. We're controlling it through the transistor switch through a very low current signal coming from pin 7. And so that is really neat. So let's see. What I want you to see is that if you look at I'm really starting to hate this little tripod of mine here. I thought it was such a cool little idea, but it is not working out very well. Okay, when you look at the GPIO pins, you see that most of them are numbered. Most of the ones that are numbered we should be able to use as a GPIO pin. Now, don't try to control ground or 3.3 volts or 5 volts or any of those that are labeled like that. But if it's just labeled with a number like a number 1 through 40, those numbered pins, you should be able to make them work. All right, so I'm going to go ahead and I'm going to do a GPIO dot clean up. And if I go like that, that will clean up all the pins. If you just want to clean up one pin, you could do like 7. You could just clean up 1. Well, it says you can't clean up 7 because it's not being used, right? Because the cleanup all cleaned them all up. But let's just say that I'm going to disconnect from pin 7. All right, and let's go to pin 11, which we had talked about before but didn't hook up to. I'm going to hook to pin 11. Okay, you see that? I'm hooked up to pin 11. So now how do we make pin 11 work? Well, I got to make sure I got good focus. I need to give you a little better focus there. Let me get a good view where you can see things. And guys, I have a really expensive Sony camera besides this webcam. And you know that that Sony camera has the same problem. The autofocus just develops a mind of its own. All right, that looks really, really good. And I'll come back to this view. Okay, so now we're on pin 11. Remember when we do the cleanup, it forgets our board configuration, so we got to go all the way back and do a set mode, okay, of GPIO, telling it to use the board numbering. And now we are going to come and we are going to do a setup of pin, this time 11. Set up a pin 11, okay, and now we would make an output on 11 as true, and boom, okay. And you guys, it becomes so bright you can hardly see it. I'll show you another thing. If you don't like using true and false, you can use 0 and 1. And so if I want to turn it off, I can put a 0 there and it turns off. And if I want to turn it on there, I can just put the integer 1, kind of like binary 0 and 1, and I can turn it on or off. Okay, guys, this has been pretty exciting. It's been a long time, and you can see that this is kind of tedious. But you can see the secret of using the Jetson Nano is you can run it from the command line, or you can open up your Visual Studio Code and you could now write in here. You would import the library, you would set it up, and then you could be turning the LED on or off based on what you saw. Also, what I want you to see is that unlike the Arduino, the secret to success in using the Jetson Nano is to not try to run your devices directly from the, you don't want to run things directly from the GPIO pin, but you want to turn a transistor on and off. Now, we use the bipolar junction transistor, which works great for an LED. What I usually use is MOSFET transistor, because there's absolutely no current that a MOSFET drives. And so a little bit better thing is to use a MOSFET for your control transistor, but it's hooked up basically the same. But the key thing that you've learned today is that if you are going to run something, you put it in a circuit with a transistor, and you use the GPIO pin to turn the transistor on and off, and then that gets its power from a external power supply. In this case, the 5-volt pin of the Jetson Nano. And that way, the GPIO pin is just a control system, turning a transistor on or off. And then if the transistor's on, have that turn your device on, whether it's something to unlock a door or open a window or an LED coming on and off. I sure hope that that makes sense. I hope that this lesson makes sense. I feel like this lesson was a little bit tedious, but it is really important. And once you see how it works, I think it's pretty straightforward. So where are we going in the future? Well, a couple of disappointments about the board. I'd mentioned several of them. A couple of other disappointments about the Jetson Nano is that you notice that on the Arduino you have those little squiggly pins for doing pulse width modulation. There's no little squiggly pins on the Jetson Nano. And so what I'm going to need to do on the Jetson Nano, I'm going to need to go in and show you how to set up and use PWM. And we can sort of simulate our analog out using PWM once I show you how to do PWM on it. And then also probably next week, the next lesson, I'll show you how to read a signal from the Jetson Nano. I showed you today how to apply a signal. I'll show you next week how to read a signal. Maybe we can look at detecting a button push or something like that. And then that would be lesson number 57. Then in lesson number 58, what I'll do is I'll show you how to do PWM so we could do something like control the brightness of the LED. Okay, hope you guys enjoyed this lesson. I've had a lot of fun figuring out how to use the GPIO pins. I hope I explained it in a way that you understand it. You guys, if you enjoyed the video, think about giving me a thumbs up. If you haven't subscribed already, run over and subscribe. When you subscribe, make sure you ring that bell so you'll get notifications of my future lessons. Think about sharing this with other people. Let's get more people involved in this technology. It's a really great way to spend your time. Okay, guys, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.